All right, the last video for this unit, we're going to be looking at solving rational inequalities. We've looked at equations, and now we'll look at how you do the ones with the less than, greater than type symbol. The steps, we want to solve whatever the inequality is. We want to solve the related equation. So we'll change it from a less than greater sign to an equal sign just to solve it. And we'll do that same way we've been in solving these other ones. Then we're going to create a number line that we can look at, find the domain, and then we're going to do some testing to see where the final result is going to be so we can graph it on our number line. All right, so first problem here. Step one is we're going to solve this, except instead of an inequality, we're going to think of this as an equals problem. Okay, so just like we've been doing, first goal is to get, so we have a common denominator. Looks like the common denominator is going to be b here. That first one doesn't have it though, so we'll multiply by b over b to that one. So now we got 7b over b minus 2 over b equals 5 over b. Now that we have everything with that common denominator, if we were to multiply through by b, all these denominators cancel out. We can just solve the numerator. So we got 7b minus 2 equals 5. Adding 2, we get 7. And dividing by 7, we get 1. So that tells us 1 on our graph is going to be a point of interest. Also, though, we want to look at what is the domain of this. Remember, domain means what numbers can you put in for x, or in this case, b. Well, when it's in the denominator, we want to make sure that we don't get any division by 0. So you want to take whatever is in, whatever the common denominator is, and make sure that whatever that denominator is does not end up equaling 0. So because we can't equal 0, these are the 2 points of interest then that we're going to be looking at on our graph. So now we're going to go over to our graph, label it so that we can fit 0 and 1 on there. And that's kind of up to you how you want to do it here. We can just go by ones. Okay, and at 0, because we know b can't equal 0, we want for sure an open circle there. At 1, okay, we got this 1. We want to look at what was the symbol here, and since it was just less than and not with the equals to, we also want to put an open circle at 1. All right, now the next thing we got to figure out is where should we shade for this one? So to do that, we're going to test some points. We're going to test some sample values in here to see which parts make it true and which parts don't make it true. And there's kind of 3 places we want to check this. I'm going to make these dotted lines here just to help us remind us. So we got to check in this area what's going to happen, in this area what's going to happen, in this area. So it kind of splits it into 3 different regions. What's happening in each of those 3 regions? So we want to pick a test one to try it out with. So for that left side, and we'll make it so it's not hard on ourselves. Let's test b equals -1 and see what happens. So if we were to put -1 into this original problem over here, what do we get? So it'd be 7 over 2, or 2 over -1 is less than 5 over -1. Let's see if what this comes out to be. So this would be the same as 7 minus 2 divided by -1 is going to be -2. 5 divided by -1 is going to be -5. On the left side here, minus a negative turns into plus, so we get that 9 is less than -5. Is 9 less than -5? That is definitely false. And so we don't want to shade then in this region to the left. There's no answers there. Okay, let's test in between these. So let's pick a point in between 0 and 1. Let's test 1/2 or 0.5. So what do we get if we put 0.5 in for all the b's? Okay, so if you go on your calculator, we could figure those ones out very quick. Let's see what um, let's see what 2 divided by 0.5 is. And hit the divide here, 0.5. So that's 4. And if we do 5 divided by 0.5, that is 10. So our problem here turns into 7 minus 4 is less than 10. 7 minus 4 is equal to 3. Is 3 less than 10? Well, that comes out to be true. So that means we need to be shading in between those. Let's just check our last region just to make sure, but I don't think this one's going to come out since we already know we're going to be shading in between. Let's test 2, a point to the right of 1 in this region. So if we test 2 and put it in there, we got 7 minus 2 over 2 is less than 5 over 2. 2 divided by 2 is 1. Whoop. Is 1, so we got 7 minus 1 on this side is less than 5 divided by 2. Half of 5 is 2.5. So if we get that 6 is less than 2.5. That is definitely false. So the only region that came out true was the one in between. That means on our graph then we want to shade in between. Only the points between 0 and 1 make this inequality over here come out to be true. So that would be our answer. And that's kind of the process of doing these rational inequalities. Let's try another one. Okay, first step again, we want to solve the related equation. So we're going to write down the exact same thing here, just with an equal sign. Okay, now we got to get a common denominator. It looks like the least common multiple between 4, 8, and 2 is in fact 8. And it looks like there's also an a here. So we want to make 8a our least common denominator. So go through and multiply each thing by what was needed to get to 8a. So this first one we got to multiply by 2 and 2. The second one already has the least common multiple. This last one we need to multiply by 4a on both top and bottom. So now we have 2 over 8a plus 5 over 8a equals 4a over 8a. And since we got the common denominator, if we were to multiply by that, it's gone. So now you got 2 plus 5 equals 4a, 7 being equal to 4a, and it looks like a equals 7 over 4, or that's also the same as 1.75. All right, so that's one point of interest on our graph. The next thing we want to do is check the domain. What can't x be here? Or a in this case. What can't a be? Well, set the common denominator that it can equal 0 and solve that. Well, here to solve that, we would want to divide both sides by 8 here. 0 divided by 8 is still 0, so it looks like, again, a can't equal 0. So now on our graph, we want to label that so that we have these two points of interest on our graph for the problem. So I don't know, let's go by halves here. So let's make that -1, 0, 1, and 2. All right, so we know it can't equal 0, so at 0, let's put an open circle. And 1.75 would be right in this area. And that would also get an open circle since it can't equal that value. Okay, now again, we want to check these different regions here. So in each of these 3 regions, what's going on? We got to pick some test points so that we know where our answer is. So first, let's pick something in the one on the left, like -1. What do we get when we test -1 here? So if we test a equals -1 and put that in there, putting -1 in for there and there, we would get 4 times -1 is going to be -4. So we got negative 1/4 plus, if we put negative 1 times 8 in the second one, we're going to get negative 8 is greater than a half. Here we need a common denominator in order to add these two fractions up. So let's times it by 2 and 2. So we got negative 2/8 plus negative 5/8 is greater than a half. That means negative 7/8 is greater than a half. Well, a negative number can't be greater than a positive number. That comes out to be false. Let's test the middle region. So let's pick 1 would be a nice easy one to test in between there. So what do we get if we put 1 in there? Well, 4 times 1 is 4. 8 times 1 is 8. It's greater than a half. Again, we need a common denominator here. Let's times it by 2 and 2. So now this turns into 2/8 plus 5/8. And we get 7/8. Is 7/8 greater than a half? Yeah, 7/8 is greater than a half. 7/8 is very close to 1. 1 is definitely bigger than a half. This part comes out to be true. Okay, just to show that that last region now isn't going to be the answer, even though we know now it's probably going to get shaded in between. Let's test 2 and see what happens if we test a equals 2. So if we put 2 in the bottom, we'd have 4 times 2 is 8. 1/8 plus 8 times 2 is 16. Is that greater than a half? Getting common denominator here, we'd have 2/16 plus 5/16 greater than a half. That adds up to be 7/16 greater than a half. It's 7/16 greater than a half. No, 8/16 would be equal to half. 7 is less than that. That one comes out to be false. Okay, so on this one, the region that made this true was the one in between, so we would shade in between here. Also, we should write out our answer, which I think we forgot to on the last one. The answer for this one then would be the inequality that would describe what's happening here. So A has to be less than 1.75, forgot the 7 there, less than 1.75. But A also has to be greater than this value here of 0. So it would be the compound inequality there. On our last one, similarly, our inequality that would describe our region here would have been A is less than 1 and greater than 0. That's the inequality that describes the graph. All right, let's take a look at number 3. On number 3, same process. Let's solve the related equation. So we want to write the same thing, but instead of a less than, equal than sign, we're just going to use regular old equals and solve. Common denominator here looks like we need a 6 and a y minus 1. So this one needs to get multiplied by y minus 1. This one needs to get multiplied by 6. And the first one needs both. So we got to times this one by 6 times y minus 1 over 6 times y minus 1. All right, so let's do a little multiplying here. On this one, if we distribute, that's going to be 6y minus 6. Plus 5 times 6 is going to be 30 over our common denominator equals, and we'll distribute here. And our common denominator now, if we multiply that, would disappear. We want to solve the numerator. So what do we get when we solve what's left here? We can put these two together. 24. We can minus 6y here from both sides. That would just be 1y, and if we add 7, it looks like y equals 31. So 31 is going to be a point of interest here. Okay, now we want to, again, do the domain. What can't x equal here, or y in this case? So put the common denominator so that it doesn't equal 0. So here, to solve that, we could distribute. We got 6y minus 6 can equal 0 if we add 6. that, divide by 6 looks like here, y can't equal 1. So that's another point of interest. So we want to put both of these now on the graph. And this one's a little bit harder to do the graph. I don't know, maybe we could go by 5s or something here. Okay, so on our graph, we know we can't equal 1. So we'll label 1 on there, and 31 would be like over here. And that one, this one's going to be a filled in one since we have equals to there. Now we got to test our regions. What's happening in those different regions of the graph? So we want to test a point that's less than 1, in between 1 and 31, and greater than 31. So for less than 1, let's test 0. That'd be a nice easy one to test. What do we get when y is 0? So if we put 0 into the original equation, we got 1 plus 5 over 0 minus 1 is less than or equal to 7, 6. Solving that, that'd be 0 minus 1 is going to be negative 1. 5 divided by negative 1. That is equal to negative 5. And you get negative 4. Is negative 4 less than 7 over 6? Yeah, a negative number is definitely going to be less than a positive number. So for our graph, that came out to be true, which means any point out this way is going to make our problem true. Now, on these ones, if that comes out true, my guess is we're not going to be shaded in between. My guess is that this point to the right of 31 is also going to get shaded. So let's test another point here. 0 came out to be true. Let's test a number bigger than 31, such as 32. Let's test y equals 32 and see what happens. So what do we get if we put 32 in place of y? Well, if we subtract that, that's 31. And then we need to add 1 to that and see what that equals. So what do we get on our calculator if we do 1 plus 5 over 31? It looks like it equals 1.6129. Okay, let's see what happens when we divide 7 by 6. Which of these is bigger? Because it's kind of hard to compare. Well, this one comes out to be 1.1666 repeating. Oop. I think I forgot a 1 here. Okay, so which of is this statement true? Is 1.16129 less than or equal to that? Well, if you notice here, the first 3 numbers here are both the same, 1.16. After that, it changes here. Here we got a 1, and then the next number here is a 6. Well, is 1 less than 6? Yeah, so this number is slightly less than the one on the right. This does end up being true. So all the points out this way are also true. So we want to shade out that way. If we test a point in between, this one is not going to work. Okay, just to show you, let's do one quick. If we pick, let's say, I don't know, a number bigger than 1, let's just pick 2. Let's say y equals 2. 2 is between 1 and 31. This doesn't come out. We'd have 2 minus 1 there. It's less than 7, 6. 2 minus 1 is 1. 5 divided by 1 is 5. And if we add that, that's 6. Is 6 less than 7, 6? No. Remember, 7, 6 was equal to what? 1.6. 6 is definitely not less than that. That's false. So our graph is now good. But the last part of this is we do want to write out what does the answer look like for this then. What inequality describes what we got going on here. So the inequality that would describe this would be that x has to be less than 1, or there's another answer to this one over on the right side here, that x is greater than or equal to 31. So this one has two parts. If there's a part going out each way, then you write it with an or statement. Either x has to be less than 1 or x has to be, sorry, we should be using y here. Y should be greater than or equal to 31. All right, one last one. Why don't you kind of pause it and see if you can do the first part where you set this equal to 0. All right, let's see what you got. Common denominator here. Looks like we want 15x as our common denominator. So make all the multiplications here. We got to times this one by 5 over 5, this one by 3 and 3, and this one by x and x. So what we're going to end up with is 5 over 15x minus 6 over 15x equals x over 15x. Common denominator's gone. So we got 5 minus 6 equals x, and that's negative 1 equals x, and that's it. We're done solving that one. So 1 point of interest is going to be negative 1. Now for your domain, set whatever the common denominator is, so it can't be 0. So here, 15x, we don't want that equaling 0. If we divide by 15, looks like x can't be 0. So now on our graph, we want to label it so we got those 2 points on there. So 0 and negative 1 are our 2 points of interest. We know for sure it can't equal 0. Open circle there. This one didn't have the equals to, so at negative 1 we want open circle. All right, so now I want you to pause the video again and test the different regions and see where you think this one should get shaded. All right, let's see what you got. On this one, test a point less than negative 1. Let's test negative 2. So if we test x equals negative 2, let's see what we get. So everywhere there's an x here, we want to plug in negative 2. So 3 times negative 2 would be negative 6. 5 times negative 2 would be negative 10. Is that less than 1 over 15? Well, here now I see that we got minus and negative, so let's make that into a plus. And then we need a common denominator. Common denominator between 6 and 10. We could do 60. I think 30 is the least common multiple, so let's multiply by 5 on this one and 3 on this one. See what we get. So we end up with negative 5 over 30 plus 6 over 30 less than 1/15. If we add those up, we get 1 over 30. Is 1 over 30 less than 1 over 15? Yeah, if you take something and cut it up 30 times and take one of those pieces, and you take something and cut it into 15 pieces and take one of those, this one, the one on the right, is going to be bigger. So this is a true statement. So if that part came out true when we plugged in negative 2, all the points this way should be answers. If you tested a point in between, let's test x equals negative half. Negative half is in between negative 1 and 0. So if you put that in, you'd have to multiply that out. 3 times negative half is going to be negative 1.5. Negative half of negative, or 5, if we multiply that by half, that'd be negative 2.5 is less than 15. This probably be one to use your calculator to help you figure out. So what's 1 divided by negative 1.5? It's going to be that. And if you hit your math button, you can change that to a fraction. As a fraction, that looks like negative 2/3. So this one equals negative 2/3. I again see we got minus a negative here, so that's going to end up being plus. And then let's see what 2 over 2 divided by 2.5 is. You get that, and as a fraction, 0.8 is the same as 8 over 10, or 4/5. So this one's the same as 4/5. Okay, Gonna need a common denominator there. Common denominator to me looks like 15. Let's times it by 5 and 5 and 3 and 3. So doing that, you get negative 10 fifteenths plus 12 fifteenths. Add that together, you get 2 fifteenths. Is 2 fifteenths less than 1 15th? Nope, 2 15ths is bigger. So you can see that that middle section does come out to be not true. The last section has a number bigger than 0, like 1. And if you do, you should see that that comes out to be true. So the graph does end up looking like that. What is the answer on this one? Well, what makes this true is if x is less than negative 1 or if x is greater than 0. So that would be how you'd write that out. All right, try some of these on the practice.